Alright, so in this video, this is the fourth video of our third unit, so it's going to cover something called completing the square. So our steps to completing the square, A, B, and C here are the same they were in factoring, because we're still dealing with quadratic equations. So we have to check to make sure our A value is 1. If our A value is not 1, we need to stop. We have to move C to the other side of the equation. We're going to calculate a fancy value called b over 2 squared. We're going to take the value we find in step 3. Step 3, so whatever b over 2 squared is, we have to add it to both. That's bold, bigger font, underlined, to both sides of the equation. We're going to factor one side of the equation, and then we're going to get y back by itself. Make sure these are copied down. All right, I'm going to do two examples with you. So we should have our steps copied down. If you do not have the steps copied down, go back, rewind the video, and go copy those down. Okay, so my first step to completing the square tells me to move C to the, well, first is my A value 1? Yes, so check. Then I move C to the other side. So we have y plus 4, I'm going to leave some space, and then x squared plus 6x. Then it tells me to calculate b over 2. Tells me to calculate b over 2 squared. My b value here is 6, so 6 over 2 squared is 3 squared, which is 9. Just 3 squared, which is 9. I'm going to add my b over 2 squared value. So whatever you get for b over 2 squared, you need to add that to both sides of the equation. Not one side, both sides. So y plus 4 plus 9, or the left side of my equation, 4 plus 9 is 13. And then we need to factor the right side. If you remember, well, let me just factor it the long way. So we need factors of 9 that multiply, factors of 9, because a times c is 9. So factors of 9 that add to 6. So I'm going to choose 3 and 3. I'll show you a shortcut in the second problem. So y plus 13, so I'm factoring the right side. And I'll write this out step by step. Okay, when we complete the square, the reason we use b over 2 squared is, is it makes a perfect square trinomial every time. Which all that means is we do b over 2 squared because every time I factor the right side of my equation, it's going to factor to half of b squared. So we calculated b over 2, which was 3, and then we squared it and added 9 to both sides. The reason we do that is every time we factor the right side, so in this case x squared plus 6x plus 9, every time we factor it is going to be x plus, or it could be x minus, x plus half of b and that factor squared. And the reason I changed it to x plus 3 squared is x plus 3 happens twice, and if x plus 3 happens twice, then that means that factor is squared. Then the last step tells me to get y by itself. So I need to move this 13 back over. And this, in yellow, is my final answer. So completing the square allows me to take a standard form equation and convert it over to vertex form. So factoring allows me to take a standard form equation and turn it to intercept form. Completing the square lets me take a standard form equation and convert it to vertex form. All right. So here, the first step says, is a equal to 1? The answer to that question, no. So before I go any further, I have to make a1. And the way I'm going to do that is a here is currently a value of 2. So I need to factor out a 2 out of this equation, or else completing the square won't work. So I'm going to factor out a 2. So 2x squared divided by 2 is x squared. 8x divided by 2 is 4x. And 16 divided by 2 is 8. Actually, let's do something first. We still want to move this 16 over before we do what I just said. So let's move 16 over. Sorry about the confusion. So let's move 16 over. Then we have 2x squared minus 8x. Now we want to factor out our 2. So let's factor out the 2. So we have y minus 16 equals 2x squared minus 4x. And I'm going to leave an opening here. Then we have to calculate b over 2 squared. And here that's negative 4 over 2 squared, which is 2 squared, which is negative 2 squared, which is 4. So we have to add 4 to the right side. And here's a catch. So on the first example here, we did b over 2 squared, and we got plus 9. So I took the plus 9 in the first example, and I added plus 9 to both sides. I'm referencing this right here. So I added plus 9 to both sides. In this, you would think I would add 4 to both sides, but I have a 4 here and a 2 here. So I'm not going to add 4 to both sides. I'm multiplying that blue 4 by that green 2. So on the left side, I actually have to add 8. And again, we're adding 8 because 2 times 4 gives me 8. And I'm multiplying that 4's inside the parentheses, so I have to multiply it by what's outside the parentheses before I add it to the other side. So if a is 1, like the first example, you just take the b over 2 squared value and add it to both sides. If a is not 1, then when you pick the value to add to the other side, you have to multiply what's inside the parentheses by what's outside, by what you factored out. All right, so on the left side, 8 minus 16 is minus 8, so we have y minus 8. I'm going to ignore the 2, and I told you a shortcut in the first one. So this is always going to factor to x squared, and the value inside is half of b. So negative 4 divided by 2 is negative 2. So negative 4 divided by 2 is negative 2, so it's always going to factor to the b over 2 value, and that factor will always be squared. That's why we call it completing the square. So then our last step is to get y by itself. So we need to add 8 to both sides. And this is my final answer in yellow. So when we complete the square, we move our c value to the other side. So we move the value to the other side with y. Then we calculate our b over 2 squared value, and we add that value to both sides. However, to complete the square, our a value has to be 1. So in the second example, if a is not 1, after we move the c value to the other side, we have to factor out the a value to force the a value to be 1. So if it's not already 1, we have to make it 1. After we do that, we still add b over 2 to both sides. But in the second example, we have to multiply that value by what we factored out in order for the equation to stay true. Once you're left with like x squared plus 6x plus 9 in the first example, or x squared minus 4x plus 4 in the second example, once we have our quadratic, we need to factor the quadratic part. And the quadratic piece of the equation will always factor to x plus b over 2, or x minus b over 2, inside parentheses, and that value will be squared. If you forget that that's always x plus b over 2 squared, then you can also just factor it the long way, and we'll get there like I did in the first example. Then once we have it factored, we still have that value over there with y. And if I'm converting this vertex form, we want y by itself. So the last thing we need to do is just move that value to the other side, and it will become our k value, if you remember our transformation or vertex form. So I know completing the square is kind of long, and I may have talked too much, but hopefully it wasn't too confusing. When you come into class tomorrow, I'll do a couple of examples with you again, but hopefully this gave you good notes and a foundation for class.